Avery, exactly does it mean to be in the 95th percentile for ACT scores?
Well, Ava, to be in the 95th percentile for ACT scores, it means that their score was higher than 95% of everybody else's score.
Hey Libby, the 95th percentile usually has a very good connotation attached to it. It seems like it's like one of the higher percentiles for like a better score. Is being in a higher percentile a good thing? Why or why not?
Well, in some cases, like ACT scores, as we were talking about, it's very good to be in the 95th percentile score because it means you got a good score. But that's not always the case. For example, if you're in the 95th percentile of a coronary calcium score, that's not good. Because I'm sorry.
Because it means you have higher risk for heart disease.
Oh, that's not good. She was in the 99th.
Ava, why are percentiles important?
Great question, Avery. Percentiles are important because they are used to interpret data, like scores in this instance, and to take measurements. To find a percentile, you take the number of values you have, usually represented by x, divided by the total number of values, usually represented by n, and then you multiply that by 100. Percentiles can also be used for measurements, like when you go to the doctor and they tell you your height or your weight and what percentile you're in. Hey Libby, can you please explain to me when, how, and why we might use the standard normal distribution for the ACT/SAT situation? What ideas about the standard normal distribution allow someone to compare SAT and ACT scores?
Yeah, so as you can see, these are the ACT and SAT scores, and they're quite similar to the normal distribution. So we can assume that SAT and ACT scores are approximately normally distributed. And as for comparison, if someone is in the 90th percentile for their ACT score, you can look right here, be like, oh, that's a 30-something. And then if they're in the 90th percentile for that, we can look at the ACT and look at that 90th percentile, and their equivalent score would be like 2137.
Great, thanks for spreading the knowledge.
Hey, but what do z-scores and standard deviations have to do with any of this?
Thanks for asking. Well, a standard deviation is the average distance from the mean, and z-scores measure the distance from the mean in terms of z-score. In terms of standard deviations, we use z-scores to convert ACT scores to SAT scores, and also to find percentiles.
So, the score we chose is 1300. And to calculate that to ACT scores, you find the z-score, so you have the score we chose, and then the mean of SAT scores divided by the standard deviation, which equals negative 0.62. And then to convert the z-score, to turn the z-score into an ACT score, you take negative 0.62 equals that number, y, which is the ACT score we're trying to find, minus the mean of ACT scores divided by the standard deviation. And then you do the thing, and you get 17.9.